Okay, so we've just started looking at loops in C, for loops, while loops, and do loops, and compared the fact that do loops always execute once, whereas for loops and while loops don't necessarily execute once. And the but this was just a comment on how a programming pattern in C where you don't increment some loop variable, you just read until you process something until you get to the end of it, and getting to the end of it terminates the loop. Okay, well, let's look at an example of this. Well, that got you. It sounds like a function call, right? There's a function call that's get C, right?
Oh,
So, and if it was get CH, so this maybe got
oh, get you.
this would be got a character, right? Or got an unsigned character, right?
hmm
So, okay. Well,
Oh, that's probably where the lingo came from.
maybe. There's lots of there's a function. Um, here's the function, right? Here's the function name. How would you think that would be pronounced?
I mean, I know, dude.
All right, but you could think that. So if you first come to this, you're going to say like, "Oh, it's a toy," right? I mean, that would be
hmm
natural. But then, lots of things in Unix are mnemonics. Or so this is alphanumeric to integer. Where with this function name, it converts like you give it 23, and it will convert. These are two ASCII codes, right? So it converts it knows how to convert. You did this, right? In one of your assembly programs, you converted, you took in characters and made the number from it, right?
hmm
And so, but this is a built-in library function, and so the name here is A to I. So oftentimes, anyway, different things. That's not really important for anything. I'm not sure why that came up. Okay, so let's write this in a function, right? Int f, say int n, int x, or maybe let's see r and n. Okay, so and then or let me see this. So f could be like for loop, right? Because so let's do see what we can do with a for loop. Let's say that we wanted to add up the integers from one to for the integers. No, let's say we just want it. Then we don't need two arguments. Okay, let's make it simple like that. Let's say that this function is going to add up the integers from one as integers 1 plus 2 plus dot 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 plus n, right? So we could say for int I equals well, we could start with 1. You sometimes start with 0, sometimes you start with 1, and then you have this would be I less than or equal to n, and then you could do I plus plus. Now it may be that I plus plus it could be let me save this so I can do this will be loops.c. Okay. Okay, so I++, it performs a similar or the same task to I equals I plus 1, right? If you probably have seen that before. Now, so you want to add up the integers, right? Well, the integers we want to add up are the I is an index variable, right? Because I is going to go from 1 to n, so it's going to run over these, and we want to sum them up. So according to the standard pattern, if you're going to do something where you run over a list, what you want to do is have some variable at the beginning that is going to be the sort of scratch pad variable that's going to hold the answer. So we'll call, so our sum is 0, right? So we're going to start with that, and then we can just take sum equals sum plus I. So it'll start with 0, and then the first iteration will get 1. Okay, and that, I think, is all you need, and we can return sum, right? Because that's the important thing. Now, so up here, what we can do is we can have a local variable. This has a local variable. Okay, so this function has a parameter and a local variable. Now, maybe let's not confuse the issue with the int I equals or just declare it out here. I know this is older C. I think this guarantees that it will execute, but the question is, what will it do with this int I? Before it didn't do this, so it just went ahead with this. So maybe this is okay. I just don't want to confuse the declaration of the variable with the loop. So this is probably okay. The question is, this looks like, because it looks like it's going to have 2 local variables. So we think we're going to have 2 local variables. Over here, we can do int answer equals f of, say, 5 or 10, right? Because we happen to know the answer for 10 is, I think, is 5,050 or something like that.
Or 5,050.
Maybe 500. Maybe we need 100.
Okay.
Maybe 10 is going to be 55. Something like that.
Okay. I could see that, but 5,000 seems outrageous.
Yeah. Yes, for adding numbers from 1 to 10, that violates your violates your notion of common sense, right? That would be a logic error if I wanted to do that. Okay, so now here we haven't done this before. Where we also look at, we have a function call, we have a function with a loop, and then now we could try to return answer, but we can't get big. Oh, we should probably put this low then, because we want to the answer has to fit into 1 byte, because otherwise it's going to be weird. If you want to see it work. Okay. Well, so this should. Oh, the one thing you have to do is, if I compiled this, I'd get a warning. One thing you do in C is you have to give a header. Okay. So this is a header. You can think interface. If you know what an interface, think interface in Java. You know, interfaces are special things you use, right, in Java, but they're syntactically like headers, and you're grouped. So the compiler uses this header to check. It's going to check that this returns an int, and this is an int. So you put an int into an int variable. Whereas if this was like a large thing. If this was like a long, which is twice the size of an int, it might complain you're trying to put a big thing in a small space, right? So, and it can, that's one of the compiler checks, the checks that the compiler does. I want to save as in cprog. Okay. So, let's just think through. There's no, this way, and then, so let's just see if this works. Loops. Okay, somewhere. Oh, look at that. See, there's this, how'd that NN get in there? That was, okay, well, let's look at the air. Look, see, undeclared, first use in this function. Did you mean N? No, I didn't. See, an NN. Okay, so it gives lots of stuff that goes wrong when you do that. Okay, so let's then go upwards. Okay, so that compiles. We can run it. Of course, these silly programs, you have to actually run it to do the echo dollars question mark. If you did echo $ question mark here, all this is going to tell you is that GCC compiled successfully. Oh, let's put this back in, right? Okay, then we'll do GCC. See, it returns 1 because it meant that there's an error. So you could, if you had a script, you could compile a program, and if you get an error, you could alert the software developer that something went wrong, because a lot of big programs have like hundreds of files and thousands of lines of code or millions of lines of code. So you have to have a special that's one thing in software engineering. You have to have a special software that controls compilation and does format checking. So you have programs that have to manage that process. Okay.
That's odd that true and false are the opposite here than they are in our writing. Like when we echo question mark, true is 0 and
that is it depends on the question. The question is, did GCC produce an error? True, it did.
Oh.
So it depends on what your sense is. Like here, okay. The point is, what you see, the 0 corresponds to like 0 errors, no errors. So false. You didn't get any errors. So it's depends on your point of view about what's going on. Okay.
That's fair.
Oops. Loops. Okay, there. Then we can do $question mark and see 55. So it worked because that's the right answer, right? I mean, we know that the sum of the numbers from 1 to n is 1/2 n times n plus 1. So if you put in 10, that's 5 times 11, which is 55. So the program does what it's supposed to do, at least in one case. And oh yeah, then and it also, let's see, if we changed this to 0, then this would do the check. I is 1, n is 0. So then it wouldn't run at all, and it would return 0. So if you put in, but also if you put in a negative number, it's also going to return 0. Okay, well, so much for that. Let's, we want to look at the, at least I want you to look at the LC3 assembly language. So we have to produce the LC3 assembly language. And see if this works. Okay, no errors. So loops ASM. Okay, so let's put the code over here and look at the assembly here. And you can see that here's main, right? And here's the, this is local variable allocation, right? There's one. So this is all the setup code, right? And then, so this is the, so here's the function call, right? A subroutine, right? So we know that this one also sets. We're not sure exactly what all this is doing because we don't have a declaration up here. It seems like all of this is part of the function call, so we have to look at that. We can tell down here that this is where you set return value. And where do we get that return value? Well, it's going to be the value of the first local variable. So this one, we're not sure exactly where it starts but this one here, LD, this is going to load R5 cross-hatch 0, which is going to be answer into R7, and this will store in the return value. So we expect that return starts here, which means this is function F call starts, and function F call ends. Okay. Now, this is F. This is the stuff for the activation. So what's going to happen is the activation record for main will be on the stack. Then when you call the function, what's going to happen is this is going to jump down here to 52. We'll look and see that, but it's going to jump down here. And this code, let's see if we have enough room up here to compare. What we can do is just copy the whole. There's through the return. New. Just so you can compare. Okay, F on the right and main on the left. And you look and you see that this code up to 24 and 7 is the same, right? But now here is the first difference, which is F has 2 local variables, right? But main only had 1. And so let's first look at the loop. So we don't have to worry about main. We just have to worry about the loop here because this is just as if, this is where the function starts. And then we can look down here. This is where you write return value and then into R3, because you're going to return some. So, but that's interesting. Oh, you write it to this, but this is, let's see, you read a variable. Well, it better be some, right? But you notice here that sum is 0, and what about I? So there's something funny business with and you can see here that the first thing here, int sum equals 0, is done first. So this is int sum equals 0, right? But so R5 plus minus 1, that memory slot is sum, right? So even though sum appears first, right? You do the instruction first, but it's organized. It doesn't where this one is separate, and so we expect that 6 here is, oh, it's back in the global data start. Here is R4 that holds the address of the global data section, and let's see. So this is R4 plus 6. So we have 1, 2, 3, 4, 5, 6. This is R4 plus 6 is address of 0. Okay. So this gets the 0. So that means that our for loop is here, and the next, and we expect that since this doesn't initialize anything, it doesn't have an appearance here. And so so that there's various things going on here with this code, right? And so we expect that, so this reads the sum. So there's a label here, there's a jump. One thing to do is to get, here's a jump. Right? You come down here. Oh, here is the branch. Whoa, that was a lot of comment symbols of the wrong type. BR. Okay, so this is where you're going to jump out, right? Because this branch must branch back, or doesn't, right? Because look, it branches to L10. So this branches out of loop, right? So, but if you branch out of the loop, where's the loop? Well, you have a jump here, right? And you jump to R7. Well, let's just see where that goes, because this is the branch out of the loop. If the loop, so if you fall through to these lines, that means the loop's continuing. Well, so that means that we have to look at R4 plus 2, R4 plus 1, 2, R4 plus 2, and that is this thing here, LC3, L5 loops. There's LC3, L3, L8. We want L5 because this one here is address of L5 loops, right? It's either 6, 5, 6, 8, and 3. I have no idea what the numbers mean. Okay, so where does this go? Where is in this one here? There it is here. So this is target target A, say, right? And so this one jumps to target A up above. So basically, if you want to read, if the loop's finished, you jump to L10 here and return. But if it's not finished, you get the place you want to re-enter the loop up here. So this is the loop, right? That means that this stuff up here has to be some kind of preparation to make a decision about when you're going to get out of the loop, right? Well, let's first look and see what crosshatch 7 is. Well, you have to be in here. Okay, 6. So R4 plus 7 is address of 1, right? Yeah, here we are. Okay. So this gets the 1, the address of the 1. This is the 1. This stores it's going to be stores 1. Well, where do you store 1? Well, it's here. So this stuff here is the I equals 1. Okay. So it's doing this part of the loop. And this is the normal assignment thing that you would do to a local variable, right? So this is local variable I is R5 plus 0. Okay. Now, so you've got the 1. So you do this first, right? I equals 1, because then it's set up. Now you have to, but you don't you don't have like this thing here. So where do we make the decision? We have to make it down here somewhere. So then this weird thing here, well, let's get, what's R4 plus, oh, I keep doing that. I keep going in this file because okay. This is R4 plus 4, right? That's 2, 3, you see, 2 plus 3 plus 4. So it's this one here, which is R4 plus 4 is address of L8. Okay. So where do we see L8? Well, let's look at it. Okay. So this is, let's look up here. It's down below. It's not up above. It's down below. There's 6. Here is L. So this is target of decision, right? Because you have to, the first thing you do when you do a for loop, you do the I equals 1 to set things up, because you can't do this comparison to decide should I do the loop or not until I has a value. So you've set I equals 1. Now it's going to make a decision. Is I less than n or not? Okay. So let me see. This then gets the address. This is actually, again, the address of the address, right? Then this is just address of L8. And this one, you jump to L8 to decide. Loop or not, right? You decide, should I loop or not? Because it could be that you're not going to loop at all, right? So the strategy is that you first go to the decision and decide if you're going to loop. If you loop, then you're going to go back to the body, right? So this is start of body of loop, right? Because the logic is you are going to jump down here, make the decision. If that decision is don't do the loop, then you just jump to L10 out of the loop, right? On the other hand, if this is true, that this is going to be negative here, whatever that means, then you're not going to do that, and you're going to fall through to this jump, which is going to jump to target A. So the logic is, if this is no loop, this is jump to target A, jump to body. So that's how it implements skipping the body if the condition is false, right? Okay, so we have here, we're looking, so we jumped to A, let's say that we jump, because we always do this. This is a universal jump. We jump to L8. So it's not a decision you make, you jump there. Okay, so what does this do? Well, it loads what's in R5 it loads into R5 into R7. What is R5? R5 crosshatch 0 is the loop variable, right? We just stored the 1 there. So this is going to be loads I, which means R7 equals 1, right? Then here, this is R5 plus 4. Well, no, it's R5. It's R5 plus 4. Yeah. So where is this going to? See, it's not going to a local variable. It's a plus sign, right? Why is it 4? What are we loading into R5?
It's 4 because you're loading the local variable again.
Well, it's not a local variable. It's a plus sign, so it's going down. So let's look at the activation record, right? Okay, so the activation record for main has to have it has to have a local variable, right? Then bookkeeping 1, 2, and 3. It's the way I'll do this without having to draw things. Make thick activation boxes because I can't draw straight lines. Okay, so this is answer, right?
Mm-hmm.
The first local variable, because this is main, right? And so this is going to be the answer. And then this is the bookkeeping for main. Okay, so we run this. When we call F, what we're going to do is we're going to have 2 local variables, right? And so we're going to have 2 local variables. So I need, but then we also have a parameter. So we have a parameter. Well, now I don't have enough space. Let's see if I can. salvage the situation. Okay. There. Okay, so we're going to have we're going to have a parameter, then 1, 2, 3 bookkeeping, and then 2 local variables. Well, let's do it. Okay, we have local parameter, 1, 2, 3 bookkeeping, and 2 oh, can't believe I did it again. Oh, I want to select that. Okay. I'll see if I can draw a line. Okay, there's the parameter. First local variable. Second local variable. No, this is parameter, bookkeeping. First local variable and second. However, we know that this is sum. Well, I have to get rid of that. Okay. This is sum. This is the activation. Well, what was that? Okay, this is the activation record for F. So it's going to be built up, and this is going to be sum, and this is going to be I, right? And then this is going to be N, parameter. And these here are the local variables of F, and this is the bookkeeping, right? This is going to be the return value. This is going to be the return address, and this is going to be mains R5. And then we have I. Okay, so okay, so what was the point? The point is that
you were wondering about the
R5 points here. R6 points to the top of the stack. What we have here to understand down here is, let's see.
Are you asking about R3 equals?
No, I'm looking to find where I had gotten.
Line 35.
Here it is, right here. It's R5 plus 4. It's on line 34. I'm going to save this. Save as F activation loops .asm. Okay. So the point is that we have this R4 here, and from the activation record, we see that it's here it is,
R5 offset
plus 4. So R5, 1, 2, 3, 4. It's N. So this is R3 equals N, parameter value, right? Well, and so that's going to be the 10, right? So that when F is running, main has written 10 in here. right? Because so main writes this. Okay, and we're out of time. Haven't even gotten through a for loop, let alone a do loop and a while loop. Okay, so we've got the parameter n here, which equals 10, right? And then we'll just finish this one thing. Then R7 now equal, well, that was the 1, right? R7 is 1, so R7 equals -1. Then you've seen this before. R7 equals -1 plus n. So it's essentially n minus 1. It's calculating n minus 1, right? So it's calculating, see, it's I is 1, is calculating n minus 1. So if n minus 1 is greater or equal to 0, right? If it's greater or equal to 0, you loop. Enter loop, right? Because if this is like 1, if n was just 1, you'd still do this once, right? Because then I would go to 2 and you wouldn't. On the other hand, so that like if I was 5 and this was 4, it wouldn't work. So it's doing a sensible thing here. And then, so you have that, and then you branch if it's negative, right?
Mm-hmm. Which exits the loop.
Which exits the loop. Because if that's that, how would that occur? That would occur if I is too large, right? If I is larger than n, you're going to branch if it's negative, exit the loop. So when do you branch? You exit when n n minus 1 is negative, which is n less than 1, right? Or 1 is when 1 is greater than n, right? And that's what you want with this. Okay, so if that's not true, you get the address of the L5 and you jump to here, and so we have the body starts here, which is, so all this stuff has got to be well, there's two things going on. One is the body starts here, but then there's also somewhere here there's the increment I++, right? So, but we will stop here and continue this on Monday.